Okay, so welcome back to part 2 of the Advanced Campus Area Network System, where we're going to do exclusively the implementation part. Okay, so in the previous video, we managed to design to do the descent part, where we came up with this topology and a little bit of comments here. Okay. All right, so suppose you've not watched the previous video. It's very important before you watch this one. Please, I will leave a link on the description part of the video or the first comment. Click on the link and get yourself the first video. Watch it, understand every concept, then come to this video, okay? All right, so, and also another thing that I would like to say, suppose you're new to this channel or you've not subscribed to our channel, please do us that favor. The same way we are putting much effort to ensure that you grasp all these concepts, to know how to put these protocols together to form one big network system. It's the same way we would like you guys to support us. Please click on the subscribe button, like this video, share with friends, and just indicate that you're present in the room. Just drop a comment below, okay? For guys from America or USA, remember this video was dedicated for you because you're secondly most watched in USA. So please, anyone from America watching this video, please subscribe. Please subscribe. All right. So without any further ado, let's get into the business. All right. So guys, you know, the work of a network engineer is to understand the case study, design the network, and implement it, and also give recommendation. Well, during the design part, there are some recommendation that we didn't include there. I've just identified them after we've finished designing this topology, and we need to include them because they are very important. Because in every network, in every case study, before I record a video, I normally sit down and try to implement it if it is feasible. Well, for this case study, I didn't implement it until I have recorded the first part. So when I was trying to implement it after recording the first part, actually, I found something that needed to be fixed, right? Okay, so what are the recommendations? IP addressing, very important. So I will open. The previous case study was not giving us the IP addressing scheme for branch network. Okay, all right. So we only had WLAN LAN networks, but we didn't. It was not specified that this one should be applied to branch or the main campus. Okay, and that's very important. So we need to edit it and ensure that the main campus has this network for WLAN, and this one for this one from the main campus, and this one from the branch campus. Okay, in regards to WLAN. Okay, in regards to LAN, the main campus will have this one, and finally the branch campus will have this one. Very important. I forgot to identify to notice this gap at the start. All right. Okay, so the delimited zone remains the same, the public IP addresses will remain the same, and the management in network just remain the same because we want to put the management network under IT department. Okay, all right, so there's no problem there. The problem was only under WLAN and LAN because it was not specified whether this network represents the main campus or the branch campus. So I've fixed something small here for branch campus, it's here, and also I've fixed something small here for branch campus under LAN. Okay, all right. So another recommendation that I would like us to do is about serial connection between the ISP and the internet. Okay, or you can just leave it that way. Okay, but at least to make the diagram look a little bit complicated. You need to use different cables, different devices, etc., etc. Okay, so what I'm going to do, I'm just going to delete this one before I comment. Okay, before I comment on the IP addressing that you've noted, let me just include the serial connection. Well, to include the serial connection, we can choose with the DCE or DTE. Okay, but we will need to choose just automatic. As per now, there are no serial ports on the router, so let's just add them. To add it, click on the router, and there's a button here. There's a 1, 0, and a minus. Just click on the 0, okay, and drag this HWIC, okay, and turn it on again. Do the same for the 2. Okay, so we can just connect it via just choose automatic. It will choose the best cable there. Okay, all right, so it has chosen serial. Good. So let's just go back and comment about the IP addressing. So the IP addressing basically, so we need to have let me just open this one. Okay, we need to have VLAN. We have two IP addressing schemes, one for HQ, another one for branch. Also LAN, one for HQ, another one for branch. Okay, and another important thing, guys, that I failed to notice is management network. So management network should be both on in each and every department switch at the HQ. Okay, so you see this one, the one that we put here for IT, this one should also be applied here. Okay, because we want these switches, all of them, to be managed remotely. Okay, so for the branch, we're not going to have a management network as per now. Okay, all right, so that is the second issue that we had. So the third issue, let's now modify the IP addressing. So for VLAN, which is 10.10.10.16 for HQ. So for VLAN, we change this 10.10.16 for HQ. Okay. Then for LAN under HQ, you can see LAN under HQ is 172.16 16 0. Actually, it should be /16. Yes, all of them should be /16. You see here. Okay, I'm sorry for the confusion, but it's very, very important that we do the right thing. Okay, all right. So the LAN should be 172 actually. Now the management network you see here, the management network should be 198, 192, 168, yeah. So let's just change management network to 192.168.10.0/24. Now the LAN here will be 172.16.0.0/ that one. Okay, then you just copy everything and paste in every department. Okay, okay, so we've done that actually. We've specified the correct IP addressing scheme on at the main campus. Now let's go to branch. So when you go to branch, actually I just try to paste whatever I copied there and delete the management network, because on this side we're not going to have management network actually. All right, so also we have VLAN 20, VLAN 50, and VLAN 15. VLAN actually VLAN 199. So guys, also finally, also at the branch we're going to have different VLANs. We don't want to have same VLANs as the HQ. Okay, we want to make a branch network a separate segment. Okay, all right, so here at the branch The LAN VLAN, let's make it maybe there was 2050. Now let's make this one like 60 90. Okay, the black hole just remain the same. There's no problem when we leave the black hole this way. Okay, all right. And then you know very well that the LAN VLAN, the LAN segment under branch should be 172.17. Okay, so we just change this to 17. Okay, then the VLAN VLAN under branch should be 1011. Okay, all right, so we just change this to 11. 10 11. Good. Then we just copy everything. That's all about the recommendation that I had. I'm going to explain them further. They're very important because if you don't implement them, a lot of things are not going to work. So as I said, this is a very big network and it needs a proper understanding and focus. Okay, all right. So the first recommendation that I had, we replaced the cables with the serial cables here. Those are crossover with the serial cables. Okay. The second recommendation that I had, we put management network under each switch, under each department. Okay. The third one was based on IP addressing. The IP addressing scheme for HQ should be different from the branch. Okay. Also, the VLANs at the HQ should be different from the branch. Okay. All right. So that's the only recommendation that I had. Now we can proceed to the second step of the configuration. Okay, which is the basic settings plus SSH plus standard ACL for SSH. Well, as you know that basic settings are very, very important for every device because it explains a lot and it provides a layer of security and maybe settings or configuration to that device. Okay, and now we are going to combine that basic settings with SSH plus ACL for SSH. Well, why do I mean this one? We need to remotely access these devices. That's why we have management network. But we only want to remotely access them from the management network, not any other network. That's why we need to do access control list for SSH, okay? For remote access. Good. So how do you normally configure? We do configuration on only one device, then replicate on, or then write the commands on Notepad and replicate or paste to all other devices. Okay, to save time. Good. So we start with this switch here, which is HSS switch. Good. So when I come here, enable config T. Okay, then just a minute. Hostname. Among the basic settings that we were asked to configure includes host names, console passwords, enable password, banner messages, password encryption, and disable IP domain lookup. Good. So host name, let's say this is health and science, health plus science SSH. Good. That's okay. All right. Good. Then line console, to protect the line console 0. You only have one user. To have a password of we need to configure password. Okay, password to be, let's just use Cisco for everything. Okay, then log in the user, authenticate the user. Whenever the line console user input this password, log them in. Okay, then exec timeout is very important for these lines. Okay, let's just say exec timeout such that the switch will log the user when they are idle for 3 minutes 0 seconds. Okay, and exit. Then enable password to protect our privilege exec mode. Okay, enable password to be Cisco. We just want to use Cisco for everything. Okay. All right. Then banner message. Banner message maybe is used to provide a kind of a warning or a guidance. Maybe you don't want everyone to log into this switch, or you don't want an authorized person to log to this switch. So you can just say banner MOTD, message of the day. Then you write any character. You write 2 characters, identical characters. Let's say today we want to write the pound, the hash. Okay. Then you come back inside those characters, and this is where you write your message. Now you can just write in caps: unauthorized access is prohibited. Okay, something like that. Then exclamation, and you hit enter. Then another thing that is remaining here is let me just check. It's disabling IP domain lookup, disabling IP domain lookup plus password encryption. Okay, so we just say no IP domain lookup. Good. Then service password encryption to encrypt all these passwords. Remember, these passwords are being displayed as in plain text. Okay, so to encrypt them, we just use that command. Okay, all right. Now we were told that we configure basic settings plus SSH plus standard ACL for SSH. So it's very simple. Now let's go for SSH. To configure SSH, the first thing you have to configure hostname. Okay. The second thing, username and password. So just say username to be Cisco for everything. Password to be Cisco. Okay. So username to be Cisco, password to be Cisco. Okay. That's the second step to configure SSH. The third step, create the domain name, IP domain name. So just say IP domain name to be cisco.com. Let's just use cisco.com. Okay. Good. Then the fourth step now is generate crypto keys. Just say crypto key generate general keys. Just a minute. General keys generate crypto key generate RSA. Good. Then the general keys to be modulus length of 1024. Okay. Crypto key generate RSA general keys, the length to be the modulus length to be 1024, and just hit enter. Okay, and now this is where now you see SSH version 2 has been enabled, so you can just confirm again IP SSH version 2. Okay, although it was enabled by default when we generated the crypto keys using RSA algorithm. Okay. All right, so finally let's now do standard ACL for SSH, which is very simple and very important, so that we protect the devices from unauthorized remote access. Okay, we only want the management network to remotely access these devices. So what do? We just create an access list. Let's just say 2. Yeah. Then permit the management network. What's the management network? You see it's 192, which is 192.168.10.0 with a separate mask of 255.255.255.255.0. Okay, sorry. Okay, then we deny any other IP apart from this one. Okay. Okay, so access list 2 still. Now just say deny any. No, just deny any. Yes, good. So let's now enter into the VTY interface, the line VTY. Okay, because it's the line VTY where we configure SSH and specify this access list. Okay, so we just say line VTY 0 to 15. There are only 16 VTY users. Okay, 0 to 15 is 16. Then we say login local. Login local basically means that use the local database. The local database is this one. Use this username and password. They use this credential. That's what the local database means. Login local. Okay. All right. So transport input SSH, so that we only accept SSH to be a method of remotely access. You know, telnet is not secure. Okay. All right. Good. So now let's bind this access list 2. Okay. So the access list 2 contain how many entries? The 2. The one permitting this network and the one denying any other network. Okay. All right. So we just say access group, access class actually, not access group, access class 2 in yes. Good. Exit and do right. That's very important, guys. Okay, so we're done the basic settings, SSH and standard ACL for SSH on this switch. So what we're gonna do, we're just going to write commands on Notepad and paste to all the remaining switches. Okay, so I just open a new Notepad and I start writing. Well, the first one was when you first log into a switch is always enable, then config T. Okay, then hostname now. Hostname to be the second switch is for which department? Let me just see. It's business. Okay, so the second switch is for business department. The second switch is for business department. Just say business boost switch. Okay, then what did we do? Line console 0. Okay, all right. Then inside the line console, you now space the password to be, I want everything to be Cisco. Okay, then log in the user. Specify the exact timeout such that the user will be logged out whenever they idle for 3 minutes 0 seconds. Okay, then exit the line console. Good. Yes, so exit the line console and configure enable password to be Cisco, everything to be Cisco. Okay, then banner message, just say banner. Be very careful with your English. Banner MOTD, then any character. Okay, then you come back inside that character and say I just want to copy this. Yes, instead writing that message again is not easy. Yeah, so banner MOTD and that one. Okay, all right, then we go for no IP domain lookup. Okay, to prevent any unnecessary domain lookup. So just copy and you disable the IP domain lookup, and also encrypt all the passwords that have been configured. Very, very important. Okay, all right. So finally we go to SSH. How do we configure SSH? Very simple. The first step, we ensure that the switch has a hostname. Okay, the second step, we configure username and password, which is very, very important for SSH. Okay, all right. So after configuring username and password, now configure IP domain name. Okay, the domain name is very, very important for SSH configuration. Good. Then after configuring domain name, now we generate crypto keys. So we just generate crypto keys using which algorithm? RSA. Okay, all right. So we just paste that one there, and also we enable SSH version 2. Okay, all right. So I paste that one there, and finally we go inside, and then we go for actually creating ACL for remote access. Okay, now to create ACL for remote access, we're just going to use this configuration for all the switches because this is what we want actually. Okay, all right, so we just paste it there. This is for permit, and the other one for denying any other IP address. Okay. All right. Then we log into we get into the VTY interface, actually the line VTY, and apply these settings. First of all, login local to accept the local database. Okay. All right. And then we specify that use SSH is as the only method for remote access. We don't want to use telnet. Okay. All right. And finally, associate that access control list. You just say access class 2 in. Good. That's all about basic settings. So exit this and say do right. All right. So we just copy and we go to this business switch and we just paste and see whether we have any problem and edit before we go to other switches. All right, we have a problem here. We have a problem somewhere here. We have a problem here. We have two problems actually. IP domain lookup, it's combined with the crypto key generate. Then here we were supposed to specify access list 2 deny any, not any. So I'll just go back here and see where the problem is. Yes, so this is where the problem is actually. I was supposed to separate that one. Okay. Alright, and also this one is any, not any. And now I copy and come back here and paste. So when I paste, you see everything is now picking up very well. We don't care, don't worry about this one because this one already we're already in that interface. Okay. All right, so that's all. So when I come back to this configurations here, what now I change is the host name. Actually everything remains the same for all other devices. So for basic settings, we're only going to do for the access switches and the multi-layer switches. We're not going to do for the firewall and the routers because these are ISP routers. We don't control them. Okay. All right. So let's do that for all other remaining switches. Now access switches and multi-layer switches. So I do that one very fast to save time. So what I'm gonna do, I'm just going to go here and edit this host name as now this is engineering switch enc that way. Okay. All right. Okay, so guys, basically we're done with the basic settings, SSH and access control list for remote access, and all the access layer switches, the multi-layer switches. Okay. All right, so let's just go back to our config guide and see what's next. So our config guide actually tells us to create VLANs. So basically what we're going to do, we're going to create VLANs and assign ports the roles of access and trunk. And for that one, I will start with the multi-layer switches. Okay. Then we move down to access layer switches. Okay. For this one, we are going to start with the access layer switches. For multi-layer switches. All right. Okay. So it is very important to understand the port roles. Okay. Very important. For example, any port connecting the multi-layer switch to the access switch should be trunk. Okay, so let's say this one is gig 012 and finally this one is gig 016. So from gig 012, 2, 3, 4, 5 and 6 should be trunk. Okay, and this interface that connects this wireless LAN controller should be access port accessing the WLAN VLAN. Okay. All right, so let's create the VLANs here. So I go here. So Cisco. Okay, config T. Good. So let's get a VLAN 10. Name it management. VLAN 20. Name as LAN. Yes, actually. And VLAN 50 name as WLAN. Exit. So remember, we have how many VLANs here? 4 VLANs, 10, 20, 50, and 199. 199, we're not going to create it on the mat layer switch. We're only going to create 3 VLANs on the mat layer switch, which is 10, 20, and 50. Okay. For the black hole VLAN, we're going to create in the access switch and put some ports under that black hole. Okay. All right. So after this one, it's very, very important that now we identify which ports actually we want to assign a role of trunk and access port. So for example, you see these 3 ports here. All of these 3 ports, we say that this is for EtherChannel, and we don't want to interfere with them here. Okay, so I can just mark something like this. Yes. Then I give it a color and indicate that there we're going to configure EtherChannel. Okay, which method? LACP. Yeah, good. So I can just so that's for LACP EtherChannel. Okay, all right. So now the 3 will be for EtherChannel. So you see this one from gig 102 to 106. They're going to be trunk. Okay, so I just go here and say interface range gig 1/0/2 to 6. Okay, switch port mode to be trunk. Good. Yes, and exit. Now we want this interface, this one, the one that connects to the wireless LAN controller, to be in VLAN 50 actually. Okay, so this interface, you can see it's gig 1010. So we just go here and say gig 1010, and remove the range here. Okay, then switch port mode access. Switch port access VLAN for WLAN. WLAN is VLAN 50. Good. Hit enter, exit, and do right. Good. So the second thing that now we do here, we write commands on the notepad and place to this switch. Okay. All right. So just find this one, and the first command that we wrote here, you could see it was all about creating VLANs. So we have how many VLANs? We have 3 VLANs to create actually. So it's VLAN 10 name to be. So we've created the 3 VLANs. Okay. So we go to the which interfaces. For example, on this smart layer switch, we're going to configure from this interface, which is gig 106, and this one is gig 102. Okay. So I was trying to be keen and ensure that from gig 1 is taken to the firewall, then from gig 102 to gig 106 connects to the mat layer switches, then from gig 107 to gig 109 are EtherChannel for both the switches. Okay. All right. So just go here and let me just open this one and copy these commands here. Yes. So just want to copy this interface range gig 102 to gig 106 to actually access to be trunk actually. Yeah. Okay. Then exit and do right. So for this multi-layer switch, for the other multi-layer switch, it doesn't have any port connecting to access. Okay, it doesn't have any access port connecting to anything. So I'll just copy and paste. So I just copy and I come here and paste. I want to bypass the password, so just say exit and paste. Good. All right. So that's all about VLANs creation and assignment of port roles on the multi-layer switches. So let's do the same on this side. Or what's important, let's finish on this side first. Being that the VLANs are different on this side, now let's finish on this side first. Okay. So when you come on the access switches, we said that it's very important actually. We said that any port from FA1 to FA2, okay, FA1 and FA2 will be trunk because they connect to the multi-layer switches. Okay, then from FA3 to 20 are going to be taken by LAN VLAN. Okay, then from 21 to 24 are going to be taken by WLAN VLAN. That's why we're going to those are where we're going to connect our access points. Then there are always additional ports on these switches. You can see them, gigabit Ethernet 01 and 02. They're going to be taken by black hole VLAN, and we shut them down. Okay, so let's just do that very fast. The first thing is very important that let me just bypass that. We create VLANs. Okay, so we create VLANs. I already created the VLANs here, so I don't need to actually write them there. So I already created the VLANs there, and just paste here. Yes, good. Now let's make FA1 and FA2 to be trunk. So interface range actually FA1/0/1 to 2. Then switch port mode to be trunk and hit enter. Exit. Good. Then we said from 3 to 20 is LAN VLAN. Now LAN VLAN is VLAN 20. So 3 to 20. Interface range 3 to 20. 3 to 20. Okay. Switch port mode access. Switch port access VLAN 20. Okay. LAN VLAN. Good. Exit. Then from 21 to 24. 21 to 24. Okay. Switch port mode access. Switch port access VLAN 50. Okay. Then there are always additional ports here that we say that it's a gig 01 and gig 02. Okay. So interface gig 0/1 to 2. Then switch port mode access. Switch port access VLAN 199. Then shut them down. Shut them. The black hole VLAN, we shut all of them down. Okay. All right. Exit and do it. So we are done with VLAN configuration on the first switch. So what we're going to do as our culture, let's write the commands on Notepad actually, and paste to all other remaining switches. So the first step, we just create VLANs. Okay. All right. So I've already done that here. You see it's here. Yes. So you create the VLANs. After creating VLANs, in every switch that I designed actually, the first two interfaces were to be trunk. Okay, they have to be trunk because I was trying to make it at least be in order. Yeah, let me say that. Okay, and then from interface 3 to 20, like we said, should be actually access port. Should be an access port accessing which VLAN? VLAN 20 for LAN VLAN. Okay, very simple. This is very simple and very important project that needs proper understanding. It needs proper understanding, I repeat. Yeah. So also from 24, now I just copy this one instead. Oops. I copy instead and paste here. Now from 24, from 21 to 24, okay, access VLAN 50. And finally, gig 0/1 to 2, access VLAN 199, and shut all of them down. Okay, this applies to all the switches at the main campus. Okay, all right, so I just say exit. Okay, do right. So this is what these are what we're going to paste to all other remaining switches at the main campus, except this one. When we reach at the IT department, I'll say something. Okay, all right, so let's just go very fast to save time. Okay, so we're under IT switch. That's we say that we'll say something. Okay, so for IT switch, I want to do something. I want to say something. Instead of the black hole VLAN, actually, we are going to delete the black hole VLAN under IT switch. Why? Because I want the two interfaces that we are putting to under black hole VLAN to be used as management interfaces. Remember, in all of these switches, we've not assigned any port a management VLAN. So we're going to assign IT switch management VLANs, some ports under IT switch management VLANs. And which ports are those ones? The last two, which is gig 01 and gig 02. Okay. All right. So basically, let's just go back to our notepad and tell you. So this one, I'm going to assign them to VLAN 10 actually, and delete this shutdown. Okay. And to make it more understandable, let's just connect some two computers here and say these are the management PCs. Okay. All right. So we connect them to which ports? Just choose copper straight through. You connect them to the last two gigabit Ethernet. Okay. All right. So these are the management PCs. Okay. Like I have just indicated there, and yes, and place two computers there. Right. So when you come back to our notepad, the only thing that changes is the VLAN number, and we will remove the part of shutdown. Okay. Then I just copy and paste. So these are the PCs that we'll be using to remotely access the devices. Okay, because they are under the management network. Okay. All right. So this is very simple. Just it's very fast. Yeah. So that's all about VLAN configuration on the HQ network. So let's move to the branch. So when you reach at the branch, I will start with the access layer switches, because this configuration that I've just written here are just identical to what we are going to paste here. Okay. All right. So the first thing here we're going to have how many VLANs? 60 and 90. Very important. So we just create how many how many VLANs here. We didn't create black hole VLAN there, so no problem, but it created itself because we assigned it. So 199. So just name this as a black hole. Yes. So here we have 60 and 90. So this is 60. And we name it as branch LAN, and then here we have 90, and we name it as branch VLAN. Yeah, good. So that's all about a VLANs creation. Good. So like we said, that the first two ports of the access switches will be trunk, and from 3 to 20 should now access VLAN 60 for branch LAN. Okay, then from 21 to 24 should access VLAN 90 for WLAN. Okay, and then from the two additional ports, which are interface gig 01 and 2, should access VLAN 199 for black hole and shut them down. Very simple like this one. Okay, I just confirm if everything is correct and we start pasting. So this configuration, we paste them to all other switches under the branch network except the multi-layer switches where we are going to do it later. Okay, alright, so let me just do that very fast. Okay, good. So we're done with the access layer switches under the branch network. So let's go to the multi-layer switches, right? Okay. So for the multi-layer switches, I'll just open the notepad here and delete some configurations here. Yes. So we're just going to create the 3 VLANs on the multi-layer switches. No problem. Okay. Then we're going to identify which ports are for trunk. That's all about the multi-layer switches here. So here you can see this is gig 105, 102, 3, and 4. And the same applies there because I was very consistent with everything I do. Okay. So from 2 actually to 5 should be trunk. That's all about the multi-layer switches here. So just say gig 1/1/0/1 actually 1/0/2 to 5, 2 to 5, 2 to 5, 2 to 5. Yes, switch port mode trunk. That's all. That's all about VLANs and trunk ports on the multi-layer switches. Okay, so that's all about the VLAN creation and assigning ports roles of trunk access ports and assigning them also VLAN IDs. Good. Alright, so that one we are done with. So we go back to our config guide to see what's next. Wow, PortFast. Alright, so guys, here we've been asked to configure PortFast and BPDUGuard to all access ports. Alright, so we're going to do this in all the switches that are here. Okay, and for this time I'm going to start with the DMZ switch. So I just click on the DMZ switch and exit, and just say interface FA0/2 to 24 actually, because I don't want to configure this as an access port. Okay, although it's a default access port, but I don't want to configure PortFast and BPDUGuard here. Okay, alright, so that one we just say interface range actually. Okay, then spanning tree, just say spanning tree PortFast and hit enter. Yes. Then spanning tree BPDUGuard enable, hit enter, exit, and do it. So if you can just unplug any port there and plug it again, it will turn green immediately. That's what we want. Also we need this one because this one is an access port. We want it to turn green immediately. So we go and configure BP spanning tree PortFast and BPDUGuard on this interface only. So it's actually we could just come to configure and we choose it. So it's 10.10. Let me just try to turn it off. We see if it's going down. Yes, it's that one. Yeah. So we just go back here, and it's a which interface? Yes. So now we just say spanning tree PortFast. Good. So spanning tree BPDUGuard enable. Good. Exit. And there was a message here. PortFast should only be connected on port connected to a single host. Good. It's connected to a single host. Oops, it's not connected to a single host. Okay, let's just give it a benefit of doubt as per now. Let's just give it benefit of doubt. Okay, as per now, if it cause problem, we'll just remove this computer. Okay, all right. So now let's go and configure PortFast on all the remaining access layer switches. We're just going to do whatever we've done here. Very simple. It's from we're just going to do from so on these other switches we're now going to do from 3 to 24 now. Okay, all right. So let me just demonstrate with this one switch. So interface range FA0/3 to 24. We only configure PortFast on the access ports. 1 and 2 are trunks. Okay, so we just say spanning tree PortFast. Okay, so spanning tree BPDUGuard enable, exit, and do it. Okay, so guys, I've noticed that there's a problem here with the interface connecting these access switches actually. So I can see all of them are down. All of them are down actually, which is so unfortunate. I need to troubleshoot that one. Okay, so all of them are down. So we can what you can just do, you can just reload the switch, the multi-layer switches. Do reload. Yes, save the configuration. Also on this side, let's just reload. Do reload. Yes, save the configuration. Good. That's all. So let's wait and see if they synchronize. All right. So another thing that I would like us to do right now is let's just open the config guide. EtherChannel, very important. Well, EtherChannel will be used between the multi-layer switches. Okay, and it's very, very important when you're doing EtherChannel. Okay, so let's go to any of the multi-layer switches. This one, I can see these ports are still turned off. So it's from this one to this one. Okay, let me just go inside them and see where the problem is. So interface gig 1/0/2 to 5. Interface range no shut. So they are up. So I do the same for the other switch. I didn't shut them down. I don't know why they shut themselves down. Maybe because of mismatch of VLANs and all the trunking protocols. Okay, all right. So just say no shut. So let's wait if they will at least be okay. All right. So I was saying that we need to configure EtherChannel on the mat layer switches, and we'll start with this switch here. Okay. All right. So we want to identify which interfaces are these: gig 107, 108, 109. Okay. So intentionally, I want to put these ports, actually the last ports. We make them EtherChannel. I want to put the last ports, actually the last 3 ports from 21 to 20 or 23, from 21 to 23. Yes, 22 now takes here 22. There's a reason why I'm doing this. I want the EtherChannel to be formed among the last ports. Yeah, so from 21 now to 23 to form EtherChannel. You can see on this side now everything's now okay. All right, so we'll just go to this smart layer switch here and configure EtherChannel. How do you configure EtherChannel? It's very simple. We just enter that range, that is those interfaces that connecting to the other mat layer switch. So it's interface range gig 1/0/21 to 23. Okay, then we create EtherChannel entry here. We just say channel group channel group 1. Okay, mode to be, we want to make it to have we were told to configure which EtherChannel method, LACP protocol. Okay, all right, so LACP normally have how many modes? Passive, active. So just use active. Active forms active, passive forms EtherChannel, but passive doesn't form EtherChannel. So be very careful. For my case, I'll use active or active passive. Okay, all right. So we just enter this interface port channel 1. Okay, and make it switch port mode trunk, exit, and do rest. So we do the same for the other switch. So this is the thing that we do for the other switch. Okay, so we just copy this and paste on the notepad. Okay, and because the other switch also add from 21 23 connected to the first switch, so we just ensure that the channel group number is the same between the 2 opposite switches. Okay, all right, then exit, and importantly we enter the port channel here that was created, port channel number 1. Okay, all right, then we make it trunk, very important, and exit, then do it. All right, so I just copy and go to the other switch, which is this switch, and paste the configuration, actually, so that EtherChannel can be formed between the 2 switches. So like we said, that we can make this one to be passive active or active active. So let me just make it passive here. The other side is active, this side is passive. It will still form, but don't make it passive, it won't form. Yeah, so the same configuration, we can paste them on this side. So on this side, what you can just modify is very simple. For the first switch, we can just make it have group 2 here, also here to be group 2. Good. Okay, so the first switch we have to leave it passive, then the other switch active. Okay, all right, so group 2 port channel 2, we come here and we paste. All right, sorry. Now for switch 2, actually we need also to configure we need also to include the 21, 22 and 23 interfaces between the two switches. Okay, all right, so we're not going to lie with the previous connection. Now we choose manually from 21. This side takes also 21 that way. And finally to 23. All right, so we can just paste them freely because we've achieved what we wanted. All right, so just paste there. So when I go on the other switch, I change this to active. And I paste. All right, so that's all about EtherChannel configuration between the two multi-layer switches. So if I can just say go here and I say and show EtherChannel port channel, so you can see LACP protocol is being used. The state is active, 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 active. The ports that are being used are here. Okay, all right, so they have been bundled together, the last port bundled together. Okay, all right, so that one will also be formed on this side. And also another thing that I would like to say here about EtherChannel configuration is about these ports turning green. Well, it doesn't guarantee that when you configure EtherChannel, those ports will turn green. Why? Because you see, we have other connection connecting to multi-layer switches. Okay, but all of these ports cannot turn green at the same time. These ports are also green. Okay, because of spanning tree protocol between these multi-layer switches and the access layer switches. Although there is a ether channel between this switch and this switch, but there is no ether channel between this one and this one. So maybe spanning tree protocol is normally persistent. Okay, and maybe you can find here is orange, or here is also orange. Okay, all right, so that's all about ether channel. So let's go back to our config guide and see what's next. IP addressing and subnetting. Guys, we've already did subnetting. You know, subnetting takes a lot of time, and we came up with a very simple table, very simple. This table, only this table, that tells us which network to use at the HQ and which network to use at the branch, and also the IP addresses between the devices. Okay, all right. So what I'm going to do is very, very simple. We're not going to touch the firewall. I'm first going to configure IP address to the multi-layer switches, then to the routers. Then finally, we can do on the firewall. Okay. Now let's start with the multi-layer switches. So before that, I'll just indicate which IP address that we are going to assign to which interface. Okay. So for example, this interface will take 10, 20, 20, 33. This interface will take 10, 20, 20, 37, something like that. Okay, so I'm done with that simple command that will guide us on which IP address to assign to which interface. So I'm going to do it very, very fast, save time. Let me just demonstrate with this multi-layer switch. So I just click on this multi-layer switch and say something. Okay. All right, so before just say config t. Before we assign IP address, remember this is a multi-layer switch. Multi-layer switch is just a switch by default, so you have to make it perform routing capabilities. So to make it function both as a switch and a router, we're just going to include a very simple command, IP routing. Okay, then we now start assigning IP address, which is to which interface this one, which is gig 101. So interface gig 101, interface gig 1/0/1. It is still a switch port. So let's make it a layer 3 interface. Just say no switch port. And that's all. Okay. Then we assign it a IP address of 10.20.20 IP add to be 10.20.20.33 255.255.255.252 because of starting notation. Okay. So the same thing that I've done, I'll do the remaining switches and the routers. Very fast, save time. Okay, so I'm going to configure IP addresses to the routers and the multi-layer switches interfaces. Okay. All right. So finally, we want us to configure IP addresses to the firewall. Firewall is very delicate. That's why I did for the routers very fast, and we have time to do for the firewall. Okay. So for the firewall, just click on the firewall, and first of all, we check which interface are these. For example, this is gig 101. So gig 101 will have .34, okay? And in firewall, there's always a concept of security zones and levels, okay? So we name the interface based on the zones that we want. For example, in a firewall, there's always an inside, outside, and DMZ. Inside is the inside network, firewall going down. Okay, the DMZ is where servers are located. Outside to the ISP. Okay, all right. So the two interfaces will represent our inside network. So each interface will give it a unique name. So for example, the two interfaces are inside network. So being that they cannot have the same name, we can just say this is inside 1, inside 2. Okay, then this is DMZ, this is outside, right? Okay, so just click on the firewall and we come to CLI and enable. This firewall, they normally have blank password, so just hit enter. Okay, then config t. Interface gig 1/1, then no shut, turn it up. Yes, it's up now. Then we assign the IP address of IP add. Before assigning an IP address, let's name it. This is nameif, give it a name. Nameif inside 1. Okay, then we give it a security level of 100%. We fully trust our inside network. Okay, then now we assign the IP addresses. IP add to be 10.20.20.34 with a separate mask of 255.255.255.252. Okay, then we go to this interface, which is gig 12. Okay, no shut, turn it up. Yes, it's up now. Then we give it a name. Name if inside 2. Both of them are inside networks. Okay, but we cannot name inside for gig 1 and inside for gig 2. It will give an error. Okay, a unique name for each interface. So inside 1, inside 2. Good. Then security level to be 100%, which fully trust whatever is coming from whatever is on our inside network. Then we give it IP address. Okay, finally we give it IP address of it's .38. Okay, all right, we exit. Now we go to this interface, which I believe is gig 13. Then no shut. Let's see if it's that. Good. So it's gig 13. So name it to be DMZ. Okay. Security level, we partially trust it, so we can just give it 70%. Okay. All right. Then IP add will be, let's just try to yes. So IP add will be 10.20.20.1. It will take the first IP address. Okay. Then the subnet mask will be /27, which is 255.255.255.224, and hit enter, exit. Then finally, we go to gig 14. Gig 14, no shut. Okay. All right. So gig 14, no shut. You see there. Name it first. Name it. It's outside. Okay. Security level of 0%. We don't trust outside network. Okay. Then we give it IP address. Can just say IP add to be 105.100.50.2. 255.255.255.252. Exit and do write. And write memory, sorry, write mem. So we're done configuring IP addresses on the firewall interfaces. So let's go to this firewall also, okay? So for this firewall, you can see this gig 11, gig 12, gig 13. So I'll do it very fast, save time actually, because I've showed you on the other side. I've showed you on the other side, yeah. So enable, that's hit enter, config T. So interface gig 1/1, name if inside 1. Okay, security level to be 100%. IP add to be 10.20.20.42. Yeah, 255.255.255.252. Exit. To no shut first. Then name if to be inside 2. Security level to be 100%. IP address to be .46. Exit. So we forgot to turn up this interface, which is no shut. Good. So let's go to gig 103, no shut. Yeah. Then name if to be outside. Security level to be 0%. Okay. Then IP add to be 205.200.100.2. 255.255.255.252. Hit enter, exit, and do write. And write memory, sorry. Yeah, so that's all about IP addressing on the devices here that you got here. Okay. All right. So so finally, what you can do here. So finally, what we can do here, let me just check on the config guide. Is all about HSRP plus Inter-VLAN routing configuration plus IP helper address. Wow, this is very important, very important actually. So before we do this, guys, I want us to do something. I want us to do this one, number 6 and number 5. I want to configure static IP address to the server farm devices and configure DHCP, right? Okay, before we can do number 5. Okay, there's a reason why I want to do that. Okay, all right, so let's just do that very fast. So we just go to I'll just indicate here. Let's say the first DHCP will take .5, the second DHCP will take .6, the next will take .7, and finally this one takes .10. Okay, all right, so let's just configure them very fast. I start with the first DHCP. I come to this one and 10.20.20.5 actually. Then I copy, come to the subnet mask should be 255.255.224 slash 27 notation. Don't forget. Then the default gateway should be .1, the IP address of this interface of the firewall. Okay. The next server you see there is .7. Yeah, good. So for the rest I do it very fast, save time. Okay, so guys, I've done static IP addressing for the server farm devices. So what we're gonna do here is just DHCP server configuration. Okay, then we finally come back to number 5. So let's just do number 7, which is very important actually here. So for the DHCP, we're going to create how many pools? 3 pools for HQ and 2 pools for branch. Okay, because we want this DHCP server to provide IP address to both branch and HQ. Very important. Okay, all right, so let's just click and remember we were told that there should be 2 DHCP servers, so that's why we have this and this one. So the 2 DHCP servers should have identical configuration, same configuration. Okay, so what I'm going to do just here, I'm just going to configure this one fully, then copy and paste it and delete this one and replace with the one that I did paste here. Then maybe change the IP address to .6. Okay, let me just show you how I'm going to do it. So it's very simple. We go to first, we check the IP addresses. That's okay. Then we try to ping if it can reach its default gateway. Default gateway is there. There is .1, which is the interface of the firewall. It can reach. That's okay. That's okay for us. Then we go to services. Then you go to DHCP. Make sure you turn this on. Okay. Make sure you turn this on, right? And everything that you find there under server pool, default server pool, turn them to 000. Just turn everything to 000. Okay, just turn everything to 000. All right, that's all about then, and save actually. So after saving, now you start creating pools. So for example, let's say we want to create HQ LAN. Let's start by management MGT. Okay, so management, we can actually have a static IP addressing or dynamic. Okay, no problem. So default gateway for management, actually, let's just come here. You just come here. So our management network you see here, it's 192.168.10.0. So let's say the first IP address will be our default gateway .10.1. Okay, all right. DNS server will always remain the same .7. All right. Then start IP address. Start allocating dynamic IP address from 168.10. Let's say .11 actually. Yeah. Subnet mask of management pool, you see it's 255.255.0 class C. Okay, then maximum number of users. Let's just assume that we want 200 users. So after editing this way, just click add. Okay, all right. So let's go to HQ LAN pool. So LAN pool here, you can see LAN here is 172.16.0.0. So we assume that our default gateway will be 172.16.0.1. okay, the first available IP, okay, under LAN. Okay, all right. And then the DNS server will always remain the same, and then start IP address to be 172, okay, .16.0.0.11, 11 just okay. Then you see subnet mask is class B. Good. Then how many users do we want? We want remember here we were told that in the future there will be more than the head counts will double. Yeah, see here. Okay, so it will double by 2025. So let's just say we want how many users? 60,000. 1, 2, 3, because this subnet mask is enough to provide the number, this number of users, and just add. Yeah. So we go to HQWLAN. So HQWLAN, you see here, it's 10.10.0 0. So we just did this one 10.10. Yeah. So the first available IP should be taken by the default gateway. Okay, we assume that way. Okay, all right. So here 10, here 10, 0.11. That's okay. Then we also want 6,000 users. The subnet mask remains the same. Then most importantly, this is wireless use, the wireless WLAN pool for Wi-Fi. And remember, we add access points in the network. So when creating this pool, then we need to specify the WLC address, wireless LAN controller address. So let's assume because WLAN network was 10.10.0. something. Let's just assume the wireless LAN controller will have IP address of 10.10.10.10.0. maybe 15. Yeah. Okay. So this will be our wireless LAN controller's IP address. Okay. All right. Then we just go back to DHCP. We just go back to our DHCP and paste this address here. We paste it there. Okay. So we tell this pool that the wireless LAN controller will have this IP address. Okay. And we save. Good. All right. So we're done with HQ. Now let's go to branch. So for branch, I just click that one and try to edit. Remember, the difference between branch and HQ was only if here was 16, then this one becomes 17, this one becomes 17, and we just add branch LAN pool. Then branch WLAN pool, if here is 10, just change it to 11, here to 11, and here is branch WLAN. Yeah, everything just remains the same, and just add. So if I can just show you that, which is very, very important. Yeah, you see, it's very, very simple here. For example, branch WLAN, you can see it's 10, 10, 11, 0, 16. It's just okay, right? Okay. So guys, we're done with the DHCP server configuration. We're done with the DHCP server configuration. So if you can just come here, you can see all the pools. So we want two DHCP server running at the same time with the same configuration. So what do? We do this. I just come here and I just mark it this way and copy and paste. Alright, so here is the new DHCP server with the same configuration. So I just take this one and put it here, okay, and delete this DHCP, right? Then I change the IP here. I change this IP address. Where is it? I change this IP address to .6 because .5 is the first DHCP server, okay? Alright, so that's all, and I at least rename it as DHCP2. Good. So that's all about DHCP server configuration. Good. So now we are free to go back to EtherChannel and HSRP configuration, which is very important for this project. If you don't execute this one well, then a lot of things are not going to work. Okay. All right. HSRP plus Inter-VLAN routing, not EtherChannel actually. Inter-VLAN routing plus HSRP. All right. All right. So how do we do this? We do this on the multi-layer switches. We do it on this side and also on this side. Okay. So we go to each multi-layer switch and we create what's called SV highs for Inter-VLAN routing. Switch virtual interface. So on the switch virtual interface, we actually append or put HSRP's parameters. Okay. Alright, so let me just show you this one. Very simple actually. So how do we do this one? Exit. So on this side we had how many VLANs? 3 VLANs. So we just create 3 SVIs. Interface VLAN 10 for management. Okay. All right. The first thing we send it IP address. IP add to be, well, during HSRP configuration, we normally have 3 things to consider: standby router, active router, and the virtual router. So the virtual router will always act as the default router. Okay. So the other remaining devices or the interfaces act as the either standby or the active route. Okay. All right. So for example, let's just show you this. Let me just show you this one. So interface VLAN 10. So let's say on this switch we want to make this all the SVIs on this switch to become active, such that when this switch is down, this one picks up. Okay. All right. So we just go to here. We just go to here. So we just say IP add to be management. For management, management was 192.168.10. something. So .1 is for virtual IP, which was the default gateway. So here the interface VLAN 10 we can just assign it .3. Okay, and then the subnet mask 255.255.255.0. okay. All right. Then IP helper address is very important. Remember, the DHCP server is located at the DMZ. So we tell all the hosts that requires IP address from this SVI to be forwarded to the IP address of the DHCP server there. Okay. So just say IP helper address to be 10.20.20.5, the IP address of the DHCP server. We have 2 DHCP servers, .6 also. Okay. All right. So now let's associate or just insert HSRP entries here. How do we do that? Just say standby Standby being that this VLAN 10, now let's just use a standby number that's equivalent to the VLAN number, okay? IP. Now we write the IP address of the default gateway, which was 192.168.10.1. Very simple and very important. HSRP. Very simple and very important. Just hit enter, exit. Okay, then we go for VLAN 20. Interface VLAN 20. Okay, and we actually we do what we send the IP address. So for VLAN 20, you know very well is for LAN. So LAN is 172.16. We make it 0.3. Okay, then the subnet mask you can see is a class B. Good. So I just repeat again. Good. That's okay. All right. And then DHCP address. I just copy this one, remains the same, and I paste there. Paste 2 times. That remains .6. So .5 and .6. Okay. Then it's very important to append or insert HSRP configuration here. So for HSRP configuration under interface VLAN 20, we just say standby 20. Okay, IP to be 172.16.0.1. Remember that is a default gateway. Exit and exit. So the same we did for VLAN 50. Okay, IP address to be IP address will be 10.10.10.0.3. okay, VLAN 50 you see here. Okay, all right, and then DHCP address, 2 of them. Then standby 50 now. IP to be 10.10.0.1 and hit enter, exit, and do right. It's very simple and very important. Okay, all right, so just check. Good. All right, so we come back to this smart layer switch, now this one. Okay, and do the same configuration as we have done on the other side, but with a different IP addresses. Let me just show you. It's very, very important that we do it the way I'm doing it. This is one of the critical areas that everything cannot work for you if you're not careful. So interface VLAN 10. Okay, so IP had on this side for management 192.168.10.2 now, because the other side was .3. Okay, 255.255.0. Okay, all right. Then DHCP address remains the same. There are 2 of them. Okay, and append HSRP settings. Just say standby 10. Don't forget the standby number should be identical. Should be identical with the first switch. Okay, standby 10. IP to be space IP to be the default gateway 10.10.0.1. Also, this one should be identical. Okay. All right. The only thing that differs is the IP address. If the other one is .3, make this one .2. The highest IP address becomes the active route. Okay. All right. Oops. Oh, sorry. Warning: address not within a subnet on this. Oops. No, to this one. Let's remove it. Yeah. So let's just write the right one. Sorry for that. That one. Yes. Exit. So let's go to for VLAN 20. VLAN 20. The IP address is actually it's 172.16.0.1. 16. So everything on this side we make .2, and this one is 172. And the solid mask on this side becomes 0 something. Okay. All right. So okay. So standby. No, DHCP address. There are two of them. Two IP addresses. Two DHCP servers. Then standby 20 now. IP to be the default gateway, okay, which is 172.16.0.1. And finally we go for VLAN 50, interface VLAN 50. Okay, IP address to be 10.10.10. Okay, so it's 10.10.0.2. And IP address, the two of them. Okay, the two of them. And now finally we do for standby, HSRP standby 50, IP to be 10.10.0.1. That's it, and do right. So guys, that's all about HSRP configuration. So we just wait for around 1 minute so that the two switches synchronize the HSRP status and we display the status. Okay. So meanwhile, let's just go to this other side, and we now write this configuration on Notepad actually and paste to the two switches. So on this side we only add two VLANs, so we just say interface VLAN 60. Okay, IP add, let's assume that we want this switch to be the active router, all the SVIs here to be active routers, here be standby. Okay, IP add to be for VLAN 60, you can just make it 172.17.0.1 0.3 172.17.0.3. okay, 255.255.0.0. okay, then IP alpha address 10.20.20.5. then there are two of them. Okay, so I just copy and paste. Okay, IP alpha address is to be 10.5 and .20. Okay, then now we specify standby, let's say standby for HSRP standby 60. I prefer to use the VLAN ID same as standby number to avoid the confusion. Okay, standby 60, IP to be, the IP address will be the default gateway of that VLAN of VLAN 60. Okay, which will be 0.1. Okay, all right. So exit that interface. All right, so we just copy whatever we've written here and paste it there. Yeah. So we change this to 90. Change this to 90, and IP address now changes from 10.11.0.3. Good. And here also changes from 10.11.0.1. And don't forget, standby here becomes 90 because of this. Okay. But so we will paste this configuration to this switch. Then when we come to this one, we'll just modify this to 2, and we'll also change this to 2. Okay. All right. So I'll do it very, very fast, save time. Okay. So we're done with the HSRP, Inter-VLAN routing, and DHCP relay configuration on the two sites, both the HQ and the campus, the branch campus. So if you can just come to this mat layer switch and display this command, and show standby brief. You see, we say that they become active router on this side, okay? So the other side becomes the standby route, okay? All right, so let's go and see what's next. Number 8, OSPF on the firewall, routers, and the switches. Very simple and very important. So guys, basically, I will demonstrate OSPF configuration on the multi-layer switches and only on the firewall. On the routers, it's similar to what I'll do on the multi-layer switches. So it's very important that you master what I'm going to do here. So let's start with this multi-layer switch. Config T. Yeah. So we're going to advertise how many networks? 4 networks on this multi-layer switch. Remember, this multi-layer switch is connected first to the firewall using this interface. Then it has 3 SVIs for management, LAN, and WLAN. So those are, it needs to advertise those IP addresses. So we just come here and router OSPF with a process ID of 15. Then a router ID. Let's just give the ID of maybe 2.1.2.2.1.2.1. Good. Then the networks. First, let's advertise this network 10.20.20.32. Okay, and then the wildcard mask for OSPF 2.5.3 because of /30 notation. Area 0. Okay, alright. So the second network that we're going to advertise are now this one. Okay, another network is 192.168.10.0.0.0.255 area 0. Another network will be to class B now. It's 172.16.0.0. This one. Finally, another network is 10.10.10. Yes, 10.10.00 class B. Okay, exit. That's all about and do that. So do show start. So I'm going to use OSPF settings on the first switch to configure OSPF on the other switch. Okay, so what I'm going to do, I'm just going to copy these OSPF entries on the first switch and tell you what I'm going to do, because this is a very big lab. We cannot be doing something over and over again. Okay, so the first thing that you have to do, you have to change the route ID. They have to have unique IDs, route IDs. If they are not unique, if they are similar, then you have a very big problem, and you can just remove that one. Then the first network, as we said, should be this one, .36 now. 36 there. Okay. Then the 3 remains the same because they are just connected. All right. Copy. And you paste here. So the same we do for this side. Also this side, we are going to advertise how many networks? 3 networks. This one, this one, this one, this one, this one, this one. Okay. Alright, so I'm just going to use whatever I did here and try to modify. So OSPF 15, the route ID will be, now let's just change this to 4. 4. Yeah. Then the first type, the first network to be, let's say I want to paste the configuration on this router. Now I change this to 40. Okay. Then the second network will be, we don't have 192 here, so I just delete 192 and remember 172.17 now. Okay, and also 10.11, not 10.10 now. Okay, so when I go to this switch, I'll just change to 44 instead of 40, and also change the route ID. Very important. If you don't change, you are attracting a lot of problems. Alright, so we're done configuring OSPF on the multi-layer switches and the routers. So now let's do it keenly on the firewall. Okay. Alright, so when you go to the firewall, it's very simple actually and very important. So you have to be very keen on the firewall. How do you configure OSPF on the firewall? Just say router OSPF, okay, and give it a process ID of 15, no problem. Then give it a route ID. Let's just say this file is 23.2.4.1, okay, that's the ID. Then the network, we need to advertise how many networks. 4 networks actually, this one, this one, this one, this one, okay. So let's start with the other one. The network is 105.100.50.0, and then on the firewall we don't write wildcard mask, okay, we just write the full subnet mask, okay. Alright, because if you write the wildcard mask, it won't work. So for 255.255.252 area 0 and hit enter. Another network is this one, which is the network is 10.20.20.0 255.255.255.224, sorry, .224 area 0. Yes. So another network is actually this one is 252. Then it's you can see it's 32 and 36. So I just change 32 and 36. Yes, exit and write mem. Yeah, so just go on the other firewall and do the same. So when you go to the other firewall, we will advertise 3 networks actually, this one, this one, and this one. So I just go here and do it very fast, save time, because I've showed you how to do it on the other firewall. So you have to be very keen, very careful. Alright, so I've done OSPF configuration throughout the network, okay, in all the firewalls, routers, and the multi-layer switches. Alright, so actually what I'm going to do is very simple. Let's just check what's next on our config guide and see now we're now entering firewall, the most challenging part in this lab actually, right? So guys, to configure firewall, the first step is always to configure what's called security levels and zones, and that's where we do IP addressing to interfaces. Okay, then also it's very important that we do routing protocol. Okay, the firewall on Cisco packet tracer is not as intelligent as the firewall in the real world production. Okay, so here we have to do some routing protocol, for example OSPF and maybe default static routing. Okay, all right, and then after we've done that, we've done security levels and zones, IP addressing, and routing protocol. So it's very, very important that now we specify the inspection policies. So when I open our notepad here, you see there are two options there are 2 points for firewall configuration. We have firewall interface security zones and levels, of which we have already done. We did that previously when we were doing IP addressing. And then number 10, which is firewall inspection policy configuration. So this is the point that we want to handle now. Okay. All right. So to do firewall inspection policy, we normally do what's called actually the first thing that we do, we should create object networks and associate them with the NAT. Okay. All right. So the first important thing that we have to do here, actually, we need to create object networks and associate them with the NAT. Okay, before we can configure inspection policy. All right. Then another important thing, default static route. In the firewall, it's very important that we do default static route such that all the routes are forwarded to the ISP route. Okay. All right. So the first thing that we're going to do default static route. So let's just go do default static route on the two firewalls. So how do we do the default static route? Very, very simple. Okay. So config T. So we just say route outside. Yes, outside route via outside interface. The outside interface is this interface. Okay, route via outside interface. Then with any IP address, okay, matching any subnet mask, okay, should go to the ISP. So ISP is having which IP address? 10 105.150.1 should go to ISP. So that default route should go to ISP. Okay, so I just paste that and edit that one and hit enter. All right, so I just copy this one and do it for the other firewall. Okay, all right, so when we go to this firewall here, we go to the branch firewall here and we just do the same. Enable, enter those they don't have password, they just have blank password. Okay, all right, so it should go to ISP. So ISP on this side, you can see it's 205. Just a minute. It is 205, 200, 100.1. 205, 200, 100.1 on this side. Sorry. Yes. So it's 205, 200, 100.1. So that's the default static route on the branch firewall. All right. So let's do what's called NAT. We create object networks. Well, we create object network based on the subnets that we have and the interfaces that we have. So for example, let me just show you how to create the object networks. So we just go to this firewall and do this. We just say object network, then we name it. Okay, so each object network should represent a subnet. Okay, so remember, we have how many subnets here? We have 3 subnets. Okay, we have 3 subnets. So the first subnet, let's just name it. This is inside 1 to outside. Inside 1 to outside. Okay, right? Then we specify the subnet that we want. The subnet here, let's start with the management, which is 172.16.10. No, management was 192 actually. 192.168.10.0. 255.255.255.0. Okay. Then we bind it with NAT. We just specify that this should be applied. You see, this should be applied with which interfaces? Inside to outside. So remember, we had 2 inside interfaces, inside 1 and inside 2. So this is another challenge. Okay. All right. Let me just show you. So we just say inside 1 goes to outside interface. Then it uses dynamic interface. Dynamic interface. Good. So that NAT will only be applied on from inside 1 to outside. Well, we never know where the traffic will follow. Let's say this switch is down, meaning inside 1 is down, right? So inside 2 has to be applied. So we must associate the same for inside 2. So let's just say exit config T. Yeah. Then now we go here and say just a minute, inside 1A now. Okay, inside 1A, inside 1A, right? 1 for this interface, 1A to apply for this one. Then we just apply these same settings here. Okay, all right. So inside 1A, then the subnet is just that one. Okay, then the NAT will just be that one. Good. Oh, now the NAT will be, sorry, the NAT now here will follow inside 2. Okay, so I just change this to inside 2. Good. And exit config T. We're done with the management network. So we do the same for LAN and VLAN subnets. So we just say now we just say inside 2 now, inside 2, then the subnet will be, the subnet now will be for the, let's start with the LAN actually. It's 172, right? That's LAN. Then the NAT we can say inside 1 to outside, first interface. Then we create another network object named inside 2 outside. Just a minute. Yes, so inside 2A outside. Okay, all right. Then we just do the same settings, and here we now say inside 2 here. Very challenging but very important. If you miss it, you miss a lot. Okay, config T. Now let's go finally to VLAN subnet. Okay, so there I'm just going to say this is now inside 3. Okay, all right. Then the subnet will be for the VLAN, which is 10.10.10.10.10, and that will be, let's start with inside 1, exit config T. So inside 3A, we apply the same settings. Yes, now it's inside 2 outside. Yeah, exit. and write mem. So we are done with the NAT configuration on that firewall. So what I'm going to do, just say show start. Then I'm just going to copy these settings actually and paste them on Notepad and paste to the other firewall, right? Okay, so I copy, close this firewall here, and I come here on the Notepad, paste them there, right? Then we come and have a discussion here. So on the branch network, in the branch network, we add how many subnets? Only 2 subnets, okay? We add only 2 subnets, all right? Okay, so what we're going to do here, let me just delete the last two, the inside 3 here. Yeah, good. So here we only add 2 subnets. The first subnet was 192, not actually 192, but 172.10.10.11, sorry, .0.0. It's a class B. Okay. All right. So I just copied this to this. Yes. Yeah. So this is the first subnet that will be translated via NAT. Okay. Then the second subnet will be .17. Now we just send this to 17. Okay. So the first NAT entry will translate this subnet whenever this subnet follows inside one interface going outside. Okay. But what if this subnet follows inside 2? It will still be translated. The same applies to the other subnet. It's very simple, but does need a little bit of understanding. Okay. All right. So I just copy and paste to this firewall. So I've saved. All right. So finally, we're now going to what's called inspection policies. Guys, I'm going to create inspection policies and bind them to both our DMZ and outside interfaces. I'm just going to create one bunch of inspection policies. Today, I'm not going to create what's called inside to outside or inside to DMZ. I'm just going to create what's called one bunch of inspection policies and apply them to both DMZ and outside. Okay, so let me just show you. So in the next video, actually, we're going to do advanced inspection policies. But in this video, it's just basic inspection policy. Config T. So I want these inspection policies. Just to create inspection policy, we normally use access control list, an extended name access control list. Okay. So I want this inspection policy to be called, let's just say access list. Let's name it. Let's just say resource access. Okay, res access. Okay, to access resource. Then it's let me just query. It's an extended access control list. Then query. Yes, permit. The first resource that we're going to access, actually permit, is ICMP from any network to any network. Okay, we want every host to ping each other. Remember, this is a basic firewall inspection policy. We're not going to put a lot of restriction here. Okay, but then we just hit enter. Okay, then another resource that we're going to, you just press on the arrow up on the keyboard, then you obtain the last configured commands. Okay, so the second resource that we're going to permit is DHCP. Well, when you are configuring inspection policy, you permit resources services based on their port numbers. So DHCP uses UDP port 67 and port 68. So just say UDP from any network to any network should access port 67, then and 68. ICMP for ping, okay. UDP port 68, 67 for DHCP. Another resource that we want to access is actually what's called DNS. So DNS uses both TCP and UDP port 53. All right, so we just try to go back to this command and try to edit. Okay, so first we start with UDP any from any network to any network equals to port 53 for DNS. Okay, then TCP also. Now we change this to TCP. TCP that one. Okay. All right. So another resource that we're going to permit, you see here, it's web port 80. So port 80 is UDP. Sorry, port 80 is TCP web. Okay, so just change this to 80. Okay, TCP any equals port 80. And the access list is called res access, resource access. Okay. All right. Then email. Email uses a lot of protocols, maybe simple mail transfer protocol, SMTP, POP3, IMAP. But in this case, let's just assume that we're using SMTP, which is TCP port 25. So TCP port 25 for mail. Okay, all right. Then finally, FTP. FTP uses two ports. I don't know whether they are. It's port 20 and 21. So let me just check if it's TCP or UDP. FTP, TCP or UDP. So FTP is actually a TCP. Yeah. So we just go TCP port 20 first, then port 21. FTP uses two ports, two TCP ports, port 20 and 21. Okay. All right. So we're just done creating inspection policies to allow access to these resources. Okay, and the most important now, we've created the inspection policy. Now we have to put them into effect. To put them into effect, we have to bind them into, put them into the interfaces. For example, DMZ and outside. Okay, we want this inspection policy to be applied when traffic is going out to the DMZ or outside. Okay, so let's just bind them to these interfaces. So just say access group res access. You have to make sure that you paste it the way it is. If you make any error, you know it will reference to a known group. Okay, res group, then query. Yes, we want it to get inside. We want to get inside the DMZ interface. The interface actually first interface DMZ. Good. All right. Good. Then we also want to get into the outside interface. So we just change this to outside. Yes, and that's all. And write mem. So we've created the inspection policies on the first firewall. So what we do, we just create the same policies on the other firewall. As we said, these are very basic inspection policies, okay? So we're just going to do them on the other firewall. So what I'm going to do, I'm just going to copy these policies to Notepad and paste them to the other firewall, okay? All right, so let me just do that very fast. The first policy that I'm going to copy is this for ICMP for ping, actually. That is for ping. Then we go for DHCP policy to for accessing DHCP, to accept DHCP port 68 and port 67. Then we go for um, DNS. DNS uses TCP and UDP port. So I paste them twice and change one to TCP, okay? TCP, yeah. TCP, good. Then we go finally to, sorry, not finally actually, but to web now. We access web. Web is TCP. Yes, web is TCP. And now we go to what's called SMTP. SMTP is also TCP port 25. Okay. So we go to finally we go to FTP, which uses two ports, port 20 and 21. So I just paste and change the one to 20, another one I paste, change this one to 21. Then we bind it to which interface now? Because the branch firewall didn't have our DMZ, now we only bind it to the outside interface. Okay. All right. So it's very simple actually. Just you have to be very keen. Very simple. Not do write, but write memory. Firewall, we just say write memory, and we copy. So I'll just confirm if everything is right here, and I go here and paste. Good. So the two firewalls, they have inspection policy configured. So what's remaining? We need to test. Wow. So testing, you know, the hardest part of every lab, because we don't know whether they will work, but we just hope that everything works. So to test, we start with DHCP. Okay. We're going to start with the DHCP. Being that we've configured the DHCP server to provide IPv4 addresses, and also we've specified inspection policy to access the DMZ resources, and finally we've specified the DHCP relay agent on the MAC layer switches. We're now free to go. Okay. So where is it? Yeah. So we can start. Let's just try, see if we will get something. Wow, I'm afraid of testing because this is a big lab. Let's just try. Good. So you can see we've successfully accessed the DHCP as service. Okay, and all these hosts can get IPv4 addresses. Okay. Alright. So another thing, the management PCs. Let's test the management PC. Wow, this is very interesting. I didn't know it will come very fast like this one. Okay. So good, the management PCs are also okay. Wow. So to the branch, now this is where things are making me go crazy actually. This is a big lab. Let's just try if the branch computers can get IPv4 address from the DHCP server. Let's just pray it gets. Wow, that's all. And as you can see, it's getting 172.17 as we specified. Wow, I'm so happy actually. Then finally, what to test is VLAN. We want to see if these access points can get IPv4 addresses. So as per now, when you click them, you can see they still have some strange. Just a minute. Let me just go to settings. Just a minute. Gigabit Ethernet. There's nothing. Radio. There's nothing. So just go to. Well, when you click DHCP, let's give it some time. See if it will get something. Whoa. It's taking long to get something. Well, you know, before I explain further, you know, this wireless LAN controller is in the same VLAN as these access points. And this wireless LAN controller, by default, it normally acts as the DHCP server, okay? So I don't want it to act as the DHCP server, because if you try to put your cursor over the remaining access point, you will see that they have picked IP address of 192.168.1. something, which is from the wireless LAN controller. You can see the IP address there is 192.168.1.3/28. And now when you come here on the wireless LAN controller and on the management interface, you see it's /28. Okay, so we want to put this IP address there so that we deactivate that DHCP function from the wireless LAN controller. Sorry. So I just put that on there, and then subnet mask here, actually, remember it was a class B. Okay. Then default gateway, don't forget the SVIs, the virtual IP. Okay. DNS, it was 10.20.20.7. Good. So that's all about that. Yeah. So it should not be able to give these wireless access point IP addresses. When I come back to statics and go back to DHCP, let's see if the DHCP is giving. Good. The DHCP now is giving as IPv4 address to the wireless access point. So if I try to hover that, you can see it's 10.10.0.17. Wow, everything is working as expected. So this one also. Good. So guys, basically everything is now working. If you can try to hover over any IP, you can see they have picked the WLAN network subnet. Okay, 10.10.0 something /16. Any. Wow. So my worry, the last worry that I have is these access points. The access points on the branch side. This is the last worry that I have actually. I doubt. Oops, no. Actually, they will pick IPv4 address. But so my worry is, okay, they have picked actually, you can see. My worry is, will they synchronize? My worry is they have picked IPv4 address. So my worry is, will they synchronize with this wireless LAN controller? Remember, this is a firewall, okay? And maybe, you know, the wireless LAN controller and the access points will communicate via firewall. And maybe, I don't know whether they use some port, the CAPWAP status. I don't know whether the CAPWAP status uses any port or anything, because they communicate via CAPWAP status. But let's just give it a benefit of doubt that it's going to work. Okay, this is a very challenging lab. Okay, and I know this one should be actually done by the people doing masters or PhD. These are beyond degree understanding. All right, because even at my level, I didn't get chance to learn all this topology during my bachelor's degree. Okay, all right. So I doubt whether this wireless LAN controller will synchronize with these access points, but let's just give it a benefit of doubt. Right? Good. So the firewall policy is functioning very well. Okay. All right. So what I'm going to do, I'm just going to turn DHCP option for all of the remaining PCs. Okay. Okay, so guys, basically I've turned on DHCP option for all other remaining devices. So what we want to do, what is next on this on the list? I just see it is wireless network. Wireless network configuration, very important. Wireless network configuration. So guys, basically, being that this is our wireless LAN controller, okay, and we want actually to configure it from this PC. So let's just assume we want to configure it from management PC. Let's leave this one, okay. Let's configure it from our management PC. Let's just assume that this wireless LAN controller is in the server room, okay, and yes, so let's just configure it from this PC here, the management PC. So the first thing, just ensure you ping it. So if it pings, then there's everything is okay. If it doesn't ping, then there's a problem. So we just try to ping it's 10.10.0.15. Good. Okay, so that's our wireless access point here. Okay, it's pinging. You can see if I try to hover over it, you can see the IP address is 10.10.0.15. So it's pinging from our PC actually. So let's just access the web page. Just go to web browser. Okay, just go to the web browser and wait until it loads. Then type the IP address of the wireless LAN controller here and hit enter. Give it some time. It will take at least 30 seconds. So these packets are normally hang when it comes to web browser access or the wireless LAN control. Okay, people, I can see people normally it's a scam. It has come. Good. So it's coming with the default. This web page that tells you that you need to set up the admin account. For this one, I'll just use admin. Let me just use admin lowercase. Then the password, I'll use Cisco at 123. Password Cisco at 123, and just click on start. Good. So here we're just told that space for the system name. Let's just say this is HQ WLC. That's our device name, HQ WLC, and then management network. The management network should be this IP address. Okay. All right. So it's 10.10.0.15. The IP that just this one. Okay. The subnet mask is a class B 255.255.0.0. Okay. The default gateway very well is 10.10.10.1. Okay, 10.10.10.01. Okay, management VLAN ID, just leave it the way it is. Don't alter it. Just leave it the way it is. Ensure that everything that you've configured is correct, and just click next. All right. So here it's telling you that configure Wi-Fi names, actually SSIDs. Okay, Wi-Fi employee network. Well, we say that in this setup we're going to do how many we had what is it, we had just a minute. Yes, we have employees, corporate users, external auditors, and guests. So we're going to create how many network IDs, SSIDs? 4 actually. So let's start with the employees. Let's say employees. Okay, employee name. Then that one will remain that way. Paraphrase. I just want to use one password for all. Cisco at 123. Cisco at 123. Then next. Leave this one. Don't alter anything. And confirm if everything that you have is right. So before I confirm, guys, I want to tell you something. If you go to any access point and try to hover it, you see the CAPOP status is indicating not connected. CAPOP status. Okay? Any access point, the CAPOP status not connected. On this side, the CAPOP status not connected. So after we have saved and the access point will have rebooted, then the CAPOP status will be formed. Okay, so let's just save. Just apply and give it some time. Don't interfere with anything. It will come. This is packet tracer, and it normally hangs when it comes to wireless LAN controller. Okay, and click OK, and just give it some time. Okay, cool. So we can just go, just give it some time. Yes, now it's here. Okay, now it's rebooting. Don't wait until it reboots. It will never come back. Okay. So what to do? Just cancel this web browser, cancel it, and come back to CMD and ping do an extended ping. Yeah, so if it's pinging, meaning it has rebooted. So you just go back to the web browser and actually you type it again. Now it's 10.10.0.15 and it will give you this error, server reset connection. So just change HTTP to HTTPS and hit enter. Good. Now you log in. Admin. The password was Cisco at 123. Cisco CCAPS at 123 and hit enter. Just leave it, give it time, it will load. Okay. Alright, so it has loaded. The first thing that we're going to do here is to check the access points in our network. Very simple and very important. To check the access points in our network, just come to under wireless tab and give it time to load. And we want to see how many access points have been associated with this wireless LAN controller. You can see it's we have a business, LACP, engineering, art LAP, and IT LAP. Now, if you now come here, so yes, so if you now come there and place the cursor over that access point, you can see the CAPOP status is connected to 10.10.0.15, providing which VLAN or employees. We've only configured one Wi-Fi network, which is employees. Even this one, yes. So RTLP is not connected. ITLP is not connected. Let's go this side. On this side, I said that this side will have problems actually. On this side, we are going to have problem. So we have to identify which ports these wireless LAN controller uses so that we can enable that port on the firewall. Okay. Alright. So meanwhile, let's go back to our wireless LAN controller. So these are the wireless LAN control. These are the wireless access points that have been discovered by the wireless LAN controller. Okay, so we need to create more Wi-Fi networks. So just come under VLAN. Okay, so when you come under VLAN, remember we have employee here. Okay, so this is employees. Just click, if you want to edit, just click on this one here and give it time to load. Okay, so the profile name is employees. So SSID, you can just say employee. You can just say maybe employee Wi-Fi. Okay, employee Wi-Fi, something like that. But the profile name is employees. Okay, and just apply and give it time to load. This is packetizer and this is wireless LAN controller. If you hurry things, if you are impatient, then you might damage a lot of things. Okay. Okay, so it has saved. So you can just go back. You can just go back and create 3 more. We want to create we had employees, corporate, external auditors, and guests. So let me do for corporates. So you can see profile name employees with VLAN SSID employee Wi-Fi. So if I come back down here and try to put the cursor here, you can now the employees has changed to employee Wi-Fi. Okay, this LAP, I don't know why it's not connecting the way we want it. Okay, we'll see that later. We'll troubleshoot that later. Okay, so let's just create another one. See here, create new, just say go. Well, so the profile name will be corporate users. Okay, now the Wi-Fi name will be cop Wi-Fi. Okay, and leave everything the way they are and create. Yes, so when you reach here, when it has created, you will reach here. The first thing, enable the status. Okay, then come under security, enable the status, then come under security tab. Okay, all right, then choose WPA2 PA2, WPA PA2. Okay, all right, so after choosing the WPA PA2, click on the WPA2 policies. Okay, all right, so after you've clicked on the WPA PA2 policy, WPA PA2 policy, then you come and this one, come and click this one. So this is where you write your password. So I also want the password to be Cisco at 123. Cisco at 123. Then you just apply. Okay, so if you come down here now, okay, go back first, then we mean. So now if you come down here under the LAPs and try to put the cursor, you now see there are two Wi-Fi's. The web corporate users providing COP Wi-Fi. Okay, so any access point. Good. All right, so let's just go back to our wireless LAN controller and create two more Wi-Fi. So I'll do it very fast this time because I've shown you how to create it previously. Okay, all right. Okay, so when just try to put your cursor over any access point, you can see now it's providing how many Wi-Fi networks? 4 actually. Even this one, 4. This one, 4. This one, it has a problem that we're going to sort very soon, and this one also 4. So whenever this one is having a problem, so I'm just going to replace it. I just want to replace it. These packages and these things normally have a lot of problems. So just say art and design LAP. Yeah, okay. Then I just replace it and connect the power. I connect the power adapter. Yes, yeah, so it's there, and I delete this one that was disturbing us. Okay guys, so when you try to hover over this the one that was bringing problems, just a minute, let's just try to place the cursor there. You can see now it's providing the 4 wireless access points, wireless networks. Okay, so whenever an AP is having a problem, just try to replace it. Okay, this packet tracer, these are virtual devices. Okay, all right, so maybe they have problems that we don't know, right? Okay, so guys, basically we want us to save the configuration under wireless LAN controller. And a very important warning that I would like to give you: whenever you're working with wireless LAN controller, ensure you save the packet tracer first. Just control S. Always ensure you frequently save the packet tracer, because wireless LAN controller normally makes the packet tracer file to hang and it closes indefinitely. And whenever it closes indefinitely, you might lose a lot of configuration. Just ensure that whenever you are starting working with wireless LAN controller, this is a warning. Whenever you are starting working with wireless LAN controller, always ensure you control S severally. After every change, just control S. After every change, just control S. Okay, but that whenever the packet is closed indefinitely, is terminated, then there is a point of backup that you have. Okay, all right. So let's just save it. Whenever you're working with wireless LAN controller, be very careful. This normally makes packets hang very thoroughly. So you can see the configuration has been saved successfully. So we just have to save and give it time to load. Okay, so you see it now. Everything has been saved successfully. We have VLAN here. We can see the wireless access point that we have in our networks. And you see at the main campus, we have 5 health and sciences, art and design, engineering, IT, and business. Okay, all right. So one thing that I would like us to do, guys, just Control S again to save so that we don't lose anything, and ensure that you've saved on this side also. Okay, click on this save. Right. Okay. So I was trying to do simple research concerning access points, the wireless LAN controller, and the access point using CAPWAP status, and I came up with this one. Enable CAPWAP status port. Well, we need to enable these ports on the firewall. See, the 4 ports, the 4 UDP ports on the firewall, so that the branch access points can desynchronize with this one, because the CAPWAP messages cannot pass the firewall because we will not enable those ports. Okay, all right, so let's enable those ports. So it's very simple. I just use the same policy that we used previously. They're all UDP. Okay, so I'll just use the same policy that we did previously, being that this access list was already linked to an interface, so we just create more entries. Okay, so the ports are 5246. All of them are UDP. 5246, 5247, 47, and another one is you see 1222. So I just copy them. These are for CAPWAP, and now these are for LWAPP, lightweight access point protocol. Yeah, something like that. So 1 2 2 2 2, 4 twos. Yeah, yeah. Then another one is 1 2 2 2 3. Yes. I hope it's going to work. Let's just pray. Not actually, but write memory. WM. Yeah. So these are the ports that are going to enable the service for CAPWAP. Okay. All right. So the rules are going to enable firewall to make the 2 devices to synchronize, the access points plus the wireless LAN controller. So we paste them on the 2 firewalls. Okay. And we hope it works. Actually, yeah. So we'll just give it some time to see if it will work. We just have to give them some more time to see if it will work. For example, we can try to request IP address again and see if it works. Yes, so I just picked IP address. Wow. So guys, you see, the branch access points have picked the Wi-Fi networks at the HQ. Wow, this is very important. Wow, this is an achievement actually. So this one, you can just request DHCP again, although it takes time, but it comes with the setting from the wireless LAN controller. Wow, so it has picked. Now let's go to branch business AP and see if it's synchronized. Well, it has not synchronized. Let's just give it some time. Okay, what about this one? Oh, this one is synchronized. You can see it is synchronized actually. Yeah, so it should be branch at and design branch at and design AP. Yeah, so this one is synchronized. The engineering has synchronized. What about the business one? It has not synchronized, so let's just wait it. What about the branch health and services? It has synchronized. So if you come back to the wireless LAN controller here and try to refresh here, just refresh, you will see the branch devices here. Okay, yes, so you can see them here. We have all the access points here. Wow, so this, guys, this is just an achievement. Yeah, this is just an achievement. Yeah, actually. So what I'm going to do, we finalize on wireless access point configuration. What I'm going to do, I'm just going to put the password. Let's say this one, all the laptops I'll connect as all the laptops I will connect as employees. Okay, all the tablets to corporate, all the smartphone maybe guests. Okay, all right. So I did very fast, save time. Okay, guys, so basically we've managed to go to each and every wireless device and put the required Wi-Fi name and password. So what's happening here? You can see the devices are connecting all over. Well, what's happening here? A wireless device will connect to only device that it considers as the highest strength. Okay. So maybe you can even see the HQ devices connecting to branch device. This is because this is a packet tracer, and we have located these devices close to each other. So you don't expect a smartphone here at HQ to connect Wi-Fi which is 100 miles away. Okay, just simple logics. What's happening here? This packet tracer and this access point on this side considers maybe this on the other side to have higher strength, even the other, this one. Okay, so it's very simple. So what's remaining here is very simple. The first thing, I'll just make this diagram look more beautiful, because we are just remaining with IPsec VPN on the firewalls, which is very important. Okay, first of all, let's ensure that hosts on this side can communicate with the host on the other side. So this is the IP address here. You can see it's 172.16.0.11. So when I go here and ping 172.16.0.11, so IP config, you see the IP here is 172.17, and I want to ping 172.16 now .0.11. Yeah, so I want just to ensure that branch can communicate with the HQ. When one PC communicates, then that's all. Others will communicate because same protocol were configured, same mechanism and same processes. Let's just give it some time. Good, so you can see it's pinging actually, although there's a lot of latency. There's a lot of latency. 50% of the packet is lost, because you can see this is a very big network. Actually, it has to follow a lot of paths, go from that PC to this switch to this one to this one to this one to this one to this one. It's a long path, so it's just worth it, no problem. So as long as there's communication, we have no problem. That's all. Yeah. So now let's make this this diagram look very beautiful first, then we can configure IPsec VPN. So okay, so guys, I've come up with the desirable color that I want to put there to indicate IPsec VPN tunnel, site-to-site IPsec VPN. So like I was saying that IPsec VPN configuring in firewall normally takes a lot of time, guys, actually. And I will recommend a site that you will use to do the configuration, okay? All right. So although I'll explain all the commands there, so let's just go to that site directly. Just type configure site-to-site VPN Cisco SA. Then you will find the first link here. IPsec VPN configuration using EK version 1 on Cisco SA. Then just click it. So this is the site. This is the site that is going to guide you on how to configure IPsec VPN step by step. You know how to configure step 1. You create crypto EK version 1 policies, executed time. Okay. All right. So and finally, it's highlights all the commands that is needed. Okay. EK version 1. You create tunnels. You create transform set. Then you associate access control list and also crypto maps. Okay. Then finally, you bind it to outside interface. So guys, as I said, this takes a lot of time, and this site will guide you step by step. So I already written all the commands that I'm going to use on the two firewalls. All right. So I'll just edit a few things. Let's just open the commands. Okay, so these are the commands that we're going to use actually here to configure IPsec VPN on the firewall, right? Okay, so these are the commands. Very simple. So what I want you to do, just go to this site, learn how to configure, and you can even copy the commands, okay, one by one. Okay, so I did learn how to configure IPsec VPN on this site. Okay, I learned how to configure IPsec VPN on the firewall through this site. Okay, so and I managed to come up with these commands. So the first time you create the EK version 1, that will remain the same for all the two firewalls. Okay, all right. So when you reach here, actually, when you reach here is when you start modifying. For example, let's say this configuration, we are going to save them on this firewall. Okay, so what I do, tunnel group this one IPsec layer 2, okay, something like that. Okay, all right. So when you reach here, tunnel group, this IP represents the public IP of the other firewall, this one. Okay, so I just copy this one. That IP address should represent the peer's IP address. So it's .2. You can see it's .2 there. Okay, and you just copy and I paste here. All right, good. So the second step that you change here, everything does remain the same. The third step that you change is now access control list. Well, how many subnets do we have on this side? We have a lot of subnets actually. We have a lot of subnets. So we create access control lists. For example, the first subnet we have is from management, which is 192.168. That one. Then it should go to the other side. So this side we also have 1 and 2, we have 172.17 and 10.11. Okay, so we just modify that. So this one will become 17.172 class B. I hope you know how to configure access control, so extended access control list. Okay, and we paste it there. Okay, also it goes to 10.11. So this is only for management network. So we need to create for LAN and WLAN, and also for we need to encrypt all the communication from DMZ to the HQ to the branch. Okay, so we don't want to expose the communication between the servers and the branch network. So let's just do this for copy. That is for management. Another access list for now for WLAN. Let's do for LAN first. LAN first will be 172.0.0. Then here remains class B. So I can just copy from this to this. Yes. So you see clearly that one first goes to LAN of branch, then it goes to WLAN of branch. Okay, any communication between them will be encrypted. Okay, so let's do the same for LAN of HQ. LAN of HQ is 10.11. Okay, 10.11. Yes, it first goes to WLAN of HQ is 10.11. It first goes to LAN of branch, then it goes to WLAN of branch. WLAN of HQ, sorry, I'm being confused a lot of times. LAN of HQ is 10.10. Yeah, right. Okay, so that's all. Oh no, not all actually. Now for DMZ. DMZ is very, very important. Let's not forget about the DMZ. Okay, we need to create rules for DMZ also. So the DMZ here we said is 10.20.20.0. It's a class 255.224. Yes. Copy and paste there. Yes. So that's all about the access control list. So when you go down, the next thing that we do, peer. Peer we said is the public IP address of that firewall, which is this one. Okay. So every command remains the same. What changes just access control list and the peer IP addresses. Okay. All right. So transform out this one, then go via outside interface. Well, that's all about it. That's all about this actually. That is all about IPsec VPN configuration on the firewall. So what I'm gonna do, write main, yes, and I copy and paste on this firewall. This was a very big lab actually. So let's see if you have any problem. If you have any problem, then you have to go back and try to troubleshoot. Yes. No problem here. Right, ma'am. That's all about IPsec VPN configuration here. Then we go to this firewall. When you go to this firewall, now we're going to reverse things. For example, this was now when you go to this firewall, the first thing we do is tunnel group. The tunnel group should indicate IP address of this firewall here, okay, which is 105.150.2. So just change that to 105.50.2. yes, this one. So I change it until I reach down on somewhere here. Those are the only thing that changes. Okay, all right, so those are the only thing that changes, and the access control list. So we're going to reverse it now. We just say from yes, so from LAN of branch to management network should be encrypted. Then we also say from VLAN of branch to management network should also be encrypted. So we just do the same. Okay, so that's all about IPsec VPN configuration on the second firewall. So I just copy everything. Please refer to the site that I've told you for more help, because there's a lot of process and I cannot include them in this video. This video has really consumed a lot of time because it required a lot of advanced protocols. Good. So that has been saved. So what I just do, just Control S to save. Right. So we're going to try to ping again. We can now close this wireless LAN controller. We now don't have any business with it. Yes. So we can now try to ping from this IP address. You can see it's let's try to ping this one. Okay, let's try to ping 10.10.049 from the branch. So the branch, let's see which from this one, 10.10.049. Yes, we want to ping 10.10.049. ipconfig. Okay, now ping 10.10.049. See here, the IP address is this one, okay? And we're trying to ping the one located at the HQ. Yeah, good. So after it has pinged, we're going to test whether IPsec VPN is functioning. Okay, so IPsec VPN is not working. So what I'm going to do, I cannot ping, meaning IPsec VPN has not formed peers. I mean the VPN gateways have not formed peers. So what I'm going to do, I'm just going to save this packet tracer and close it and open again and let it synchronize. Okay, so guys, I've managed to restart the packet tracer. So I'll just go to any PC and try to ping let's just say ipconfig. Okay, and I'm just going to ping any IP address at the branch at HQ. Okay, so let's just assume that we want to ping the default gateway of the VLAN at HQ. Then just give it some time, because of IPsec VPN it will take time to deliver the packets. Yes, so you can see now it's pinging. Yeah, so it's pinging, right? So if you can just go to any firewall here and we say first of all, I was trying to see if they are form peers. Okay, so how to see how they are form peers? You can just say show crypto ISACMAP SA. Okay, show crypto ISACMAP security association, and you can see the role is initiator and the peer is this one, which is IP address of this firewall. Even if you come on this file also and you just say show crypto ISACMAP SA, you can see the peer is that one, which is the IP address of the other firewall, and the role is responder. So to see how many packets have been encrypted is very, very simple. Just say show crypto IPsec security association and you hit enter. And now guys, you can see a lot of packets have been decrypted here. Okay, and if you continue scrolling, we want to see where we were pinging from the computers 172, actually 172.17 to 10.10. So we want to see that entry here from 172 to, this is 172 to 192. You can see them here, okay? So we want 172 to 10.10. So we just scroll and see. We want 172 to 10.10. 172 to 10.10. 172 to 10, yes, so 172 to 10.10, you see. So here we will find the number of encrypted packets here. So meaning our IPsec VPN is fully operational. And guys, we have achieved what is required on the case study here. This was a very big packet, very big lab, I mean, that required deep understanding, keen interest, and you have to be very focused when you are trying to understand how to implement this project. So basically, guys, this is all about this project. If you need this project, please subscribe to this channel, like this video, share, and join the channel membership. Write me a message or just drop a comment below. I will see a membership badge alongside your name, and I'll send the packet tracer file to you directly. So that marks the end of this advanced campus area network design and implementation. Let's meet again when we're going to do other big labs. Thank you so much and bye. I wish you all the best, guys, and may the Almighty bless your career, your families. Alright, thank you so much and bye.